when we're simplifying rationals, what do we want to do first? Dejanique, you said set the denominator equal to 0. So that is when we're finding domain. So we'll get to that. Don't forget that. But when we're simplifying, we're just trying to make it as small as possible. Kristen, were you saying something? It's not wrong, but it's not what we need in this case. So greatest common factor is going to come up next. Not yet, though. So the first thing you want to do when simplifying rationals is see if you can factor it. So simplify the numerator and denominator as much as you can, and then see if anything cancels out. So can we simplify this numerator? How? We can factor out a 2. And what's left? And can we factor the denominator? What do we get? So we want factors of -12 that combine to give us -1, which are -4 and +3. Yeah. I was supposed to use a different color. I'm going to scan these notes and post them since we're not following what was already up there. All right. Now what? Can we? Are they the same? So this one is 4 minus x. This one is x minus 4. They're not the same. But we can make them the same. How? Any ideas? What if we factor out a negative from here? If we factor out a negative, the 4 becomes negative and the x becomes positive, right? Does that step make sense? Okay. So these two were not the same. They look the same, but they're not exactly the same. Over here, the 4 is positive, down here is negative. Over here, the x is negative, down here is positive. So to get them to be the same, we have to factor out a -1 from either this one or this one. All right, now we can cancel them out because they're the same, and everything is being multiplied. So we get negative 2 divided by x plus 3. Any questions on that one? Yeah, if they look exactly the same but opposite signs, you always take out a negative 1, yes. Good question. Any other questions? If not, take a look at number 2. Let me know what we should do. You guys can also respond in the chat if you don't feel like talking. Yeah, look for GCF in the numerator and denominator. What's the GCF here? So the GCF in the numerator is 4. If we take out 4, what's left? And what's the GCF in the denominator? X. If we take out x, what's left? Still plus 1. All right, so what is this fully simplified? So Angel brought up a good point. The best thing to do when simplifying rationals is always to look for GCF. See if you can factor out GCF. And if you can't, like number 3, the only thing they have in common is 1. So we can't factor out GCF because it won't change anything. When that doesn't work, we move on to seeing if we can factor it. So can we factor number 3? So what? All right, Kristen, you're done. Let someone else try. But yes, numerator is x minus 1, x minus 1. And denominator is someone other than Kristen. I agree with the 1 and the 2, but not the signs. Yeah. We want the bigger number to be positive because this middle number is positive. All right, so what is this fully simplified? Any questions? All right, next is multiplying and dividing rationals. Who remembers how to multiply and divide rationals? Kristen, you're allowed to talk again. No one remembers. So when we multiply rationals, we just multiply straight across. So the first step is to make it into one big fraction. The second step is what Angel told us to do, which is what? Right. So we want to find the greatest common factor in the numerator and the denominator. So is there something we can factor out of this first parentheses? Yeah, we can factor out an x. Can we factor anything else? What does that become? Exactly. All right, now we're back to what we were doing in the numerator. We have to simplify this fraction. I said numerator, I meant we're back to doing what we did up top. So can we simplify this one? Is there anything we can cross out? Yep, we have x minus 5 up here, x minus 5 down here. What else? Yes, we can cancel out this x with this x. What else? What else can be simplified? The hint is it doesn't have an x. Yes, the 10 and the 4 can be simplified to what? Yep. So when we clear everything out the way, we're left with five x plus 5 divided by 2. So first thing we do is combine it into one fraction. We can do that when it's being multiplied. Second thing is to expand it as much as we can. Factor out GCF and factor problems like this one. And then after we factor it, see if we can cancel anything out from the numerator and the denominator, including the numbers. All right, any questions on that one? Yeah, you do it for both. Yep. Another good question. All right. Dividing. Do you remember what you're supposed to do for dividing? Yes. So division is the same as multiplying by the reciprocal. So we start by flipping the divisor, which is what we're dividing. And when we flip it, what happens to this sign? Yes. So once we flip the divisor, the second fraction, we're now multiplying. Keep, change, flip. Yep. Yeah, I can put that on here too. So after we're done with this part, I'm going to scan it and post this note. All right, so we keep the first one. I like that. Thanks for sharing it. We change it to multiplication and we flip the second one. All right. This is multiplication, so we can combine it under one fraction. All right. Any GCF to take out? No, so what do we do? Yep. Try to factor it. Christian, I'll let you do one of them. Yeah, pick one and factor it. All right. Who wants the second one? Factors of -8 that combine to give us +2. Yes. All right, Ryan, you're done. Factors of negative 15 that combine to give us negative 2. All right, Dejanique, you're done too. And last one. 4 and 4. Thanks. Good teamwork. All right. Now we have a big fraction with everything being multiplied. We can start canceling out like terms. What can we cancel out here? Yeah, we have x plus 4, x plus 4, x plus 4, x plus 4. And we're left with x plus 1, x minus 2, and x minus 5, x plus 3. And if we expand that out again, what does that become? By expand, I mean distribute or FOIL. I did the hard one. What's next? Almost. And what about the denominator? So either one of these is fully simplified. Any questions? If it helps, you can rewrite it so it looks like number 5. See what that looks like. So this one big crazy complex fraction can just be turned into something that we already saw how to solve, right? So what do we do first? Yep. All right. What do we do after we keep, change, flip? All right. Now what? Do we have one? Is there a greatest common factor we can factor out? No. So what can we do? Yes. X plus 3 is already factored. Who remembers how to factor cubes? No, there was a formula for it. Remember soap? Yeah, I did. Remember the soap is an acronym. All right, so it is same sign. That's the S. Opposite sign. And then the last one was always plus. You telling me you don't remember this? Okay, well, my bad. Yeah, so when we have difference of cubes, when we factor it out, we get a minus b. The first sign is always the same as the original. And then we have a squared, ab, and b squared. The second sign is going to be the opposite of what we put the first time. And the last one is always plus. Right? So remember, we had to find base terms, and a and b are what the base terms are, right? So looking at this one, what is the base term for x cubed? Do we all know what I mean when I say base term? So base term is what the number you have to cube to get x cubed. So what do we have to cube in order to get x cubed? Right, so that means a is x. What do we have to cube to get 8? So 2 is b. Does that make sense now? Okay. So we just take A and B. Huh? Then we can't use this formula. We'd have to find another way. That's a good question. All right, so first one we have a minus b, we have x minus 2. What's a squared? Just x. And then what is ab? What's a times b? Yes, 2x. And then what is b squared? 2 squared, which is 4. Any questions on that one? What about x squared minus 4? Can we factor that? Yes. These two are perfect square. X squared is a perfect square and 4 is a perfect square. So this is a difference of squares. Can we factor this one? Negative 4 and 3, yes. All right, now everything is completely factored out. We can start crossing stuff out. What can we cross out? We can cross out x plus 3 and x minus 2. Yes. So we're left with x squared plus 2x plus 4 divided by, can we FOIL this one? We can. I'm asking you, can you do it for me? I'll do the hard one. What's the rest? Yep. All right. When we're adding and subtracting fractions, what is the one thing we have to have before we can do anything? Yes. When we're adding and subtracting fractions, we have to have common denominators. The same thing goes for when we have expressions like this one. So is there anything we can multiply to x to get x squared minus 4? To multiply to x to get x squared minus 4. The answer is no. We can't multiply anything to x to get x squared minus 4. And there's nothing we can multiply to x squared minus 4 to get x. So the only thing we can do to get common denominators is to multiply the same thing to both sides. So x squared minus 4, top and bottom on this side, and then x on this side. You remember that? All right, so what's x times x squared? Yes, x cubed. No trick questions. What is x times x squared minus 4? And then negative 1 times x squared minus 4, we get you will after you distribute the negative, yeah. All right, so after we multiply this denominator to this side, top and bottom, and this denominator to this side, top and bottom, now they have common denominators, right? And now that they do have common denominators, we can combine it into one fraction. And this is where we distribute the minus, right? Brian? Any questions on this one? Sometimes to make life easy on yourself, it's a good idea to factor out your problems, because sometimes you may be missing just one thing from each one. So for example, number 8, let's see if we factor it out. Let's see if we factor it out, will we be able to find something easier to do than multiplying this whole thing to this side? So what is x squared plus 3x plus 2 factored? What about x squared minus 1 factored? All right, so what is this side missing that this side has? So this side is missing an x plus 2, Kristen, and this side is missing an x minus 1. I'm assuming that's what you guys meant. Yeah, let's go with that. So this side is missing an x minus 1. We multiply that top and bottom. And this side is missing an x plus 2. So we multiply that top and bottom. Does that make sense? Instead of multiplying this whole trinomial to top and bottom over here, we were able to figure out that it was only missing one thing. So we have x times x minus 1. What is that? X times x minus 1. Almost. And then we have 2x minus 3 times x plus 2. Yeah. You said another one. So we have 2x squared, and then negative 3x, and then we have 4x, and then minus 6. Right? Two times 2x. Any questions so far before we move on? All right, so now we combine things in the numerator. What can we combine? Yeah, we have 1x squared and 2x squared. That becomes 3x squared. And we have negative 1 minus 3 plus 4. What is that? Yeah, that's 0. So negative 1 minus 3 is negative 4. Negative 4 plus 4 is 0. So we don't have any more x's. We're just left with minus 6. Can we factor anything out from here? Will it help cancel out anything in the denominator? Let's see, if we factor out a 3, we get x squared minus 2. Okay. Nothing cancels out, so we're done. Any questions? So we got that from when we tried to get common denominators. So when we multiplied x minus 1 to this side, then we got x minus 1, x plus 2, x plus 1. And for this side, we have to multiply by x plus 2, and we got the same thing, x minus 1, x plus 2, x plus 1. So that is our common denominator. Any other questions? All right, last one. Another complex fraction. So there are two different ways to solve this one. The first one method is to get rid of all denominators. So we're going to figure out how to remove these, the 2 and the x and the 4, all with one move. Any idea on how to do that? What are you multiplying by? Yes, you do multiply, but by what? Not exactly. So we're trying to figure out one thing we can multiply to the top and the bottom to get rid of the 2, the x, and the 4. So we look for greatest common factor. Between the 2 and the 4, what's the greatest common factor? It's not greatest common factor. I'm going to just show you. So in order to get rid of the 2 and the 4, we would have to multiply by 4, right? So 4 times 4, they cancel each other out because this one is, I'll just work it out and show you. So if we multiply top and bottom by 4x, and we distribute it to both of these, and we do the same thing, we distribute it here, we get I'll explain it in a little bit. So we wanted something that would cancel out this 2 and this x and this 4. So in order to cancel out this x, we have to multiply by x, right? And then in order to cancel out this 4, we have to multiply by 4. And so we're just multiplying by 4x divided by 4x, which is just 1. So what we have in the bottom, we have to have at the top, otherwise we're changing the problem. All right. So we chose x because we wanted to cancel out this x, and we chose 4 because we wanted to cancel out this 4, and it also cancels out this 2. Does that make sense? So if we distribute the 4 over here and over here, this is what we get. Now we can simplify. What's 4x divided by 2? And what is 12x divided by x? What is 4x squared divided by 4? And what is 12x divided by 4? Did that make any sense? Are you sure? Or are you just saying it? Okay. It cancels the 2 because 4 divided by 2 gets rid of the denominator, and we have 2 left up in the numerator. So it's like, okay. So we wanted to use one number that would cancel both the 4 and the 2 out. And that one number was 4. The second method is to just divide. So when we're dividing fractions, remember that's the same thing as multiplying by the reciprocal of the denominator. So we get 1 over 2 plus 3 over x times 4 over x plus 3. We still following? All right. And now before we can multiply these two, we have to get one big fraction in here. How can we do that? Yeah, we have to get the same denominator. How? Yeah. So we have to multiply this side by 2 and this side by x. So we get x divided by 2x plus 6 divided by 2x. Because they had common denominators, we could just combine it into one fraction. All right? Now we can multiply. And when we're multiplying fractions, we just multiply straight across. We have 4 times x plus 6 divided by 2x times x plus 3. Before we multiply, can we simplify anything? Yeah, we can simplify the 4 and the 2. So this becomes 2 and this goes away, because 4 divided by 2 is 2. And we're left with 2x plus 6 divided by x times x plus 3, which is equal to 2x plus 12 divided by x squared plus 3x, which is the same thing we got up here. So whichever way is easier for you, either way works.